Hello and welcome to 22nd lecture of course on corrosion, environmental degradation and surface engineering. Topic of this lecture is a digitization of established curves and data driven approach. Now this topic is very recently, maybe say 3-4 years back, people have started using this kind of work, and we know that we do not have many established relations among the variables. We often use sophisticated methods, but question comes whether those methods are going to be very useful even the operating time or will not be useful. Our experience indicates that very sophisticated finite element method, boundary element method, they are very good at the beginning or maybe the design stage. But when it comes to the maintenance or operating condition time, then data driven approach will be providing a better results compared to those methods. So, how do we really go ahead? As I mentioned is more like recent approach, current approach. So, we want to really give one complete lecture, we want to cover this in one complete lecture, and maybe next lecture we will be giving little more details on this. So, first question comes, so what is the meaning of digitization? Even though I know most of the students will be knowing this term, however, for my purpose I want to really define, and we say the digitization of established curve. And what is the meaning of established curve? If you go through the engineering books, mostly the data are being presented in a graphical form in curves. And then there are well established curves which they have been utilized maybe say over more than 30 years, 40 years in engineering discipline. So, what we say in engineering, research and economics, in economics also we present the results in graphical manner. So, this graphical representation of data is very common. Now, when we want to utilize these data for the optimization, for optimum maintenance of the system, we really require the digitization of that, we really require the data. And in previous lecture we covered the better objective method, where we need to really give the numbers and then give weights to the different variables. That cannot happen without digitization, without really numerical values. So, that is why we say digitization is a process of converting analog or graphical representation to digital one or digital form, and then it can be done either by scanning or it can, we need to really pick up the data from curve or graph and directly type one by one those data. Either we can scan if there is a software available, or if software is not available, we need to do the plot complete graph or the curve on the graph paper, and then we find x and y points, and then we tabulate those and then give to the software or maybe input to the software. So, this is very important for the digital platforms or algorithms, particularly when we are talking about a MATLAB algorithm we will be developing and will be using. For those algorithms we really require this kind of data. Now, coming to the data driven approach, we see that optimization or maintenance strategies can be decided based on the data. Now, from where those data will come? One is that from a digitization point of view, and if we have a data, do we really filter those data and then really come up with a meaningful data? Quite possible we have 10,000 data, but will I be using all 10,000 data? Or we really require some data driven approach to filter, to come up with a much lesser number of data and take a proper decision with the we say which is really required for the one situation 1 or situation 2 or situation 3, and the decisions will be based on the available data to us. Quite possible we may require additional data, then we may really require experiments to be done on a setup. So, what we say, the data driven approach is making decision or gaining insight. Sometimes we want to really enhance our understanding based on the data analysis. Now, this is an important thing, many times we do not know the relation, and then when we do the data analysis we can find out some relation. So, that is why we say the finding hidden relation and trends. It has been utilized in an Excel sheet trend analysis for the number of years, but we want to refine that. What we use the word something like a curve fit method, and we develop a relation. Will that curve fit relation or curve fit method will be appropriate in every situation, or we really require some modification? That will be covered in the present lecture. So, we see in the we have a large data set, and then we want to really figure out hidden relationship or maybe the trends, then we really require some statistical method. Curve fit method also is a statistical method, and we use a good algorithms for that. However, we are trying to emphasize on the machine learning, which really is a more like current approach, and then we get many advantage when we go with a machine learning approach. So, based on this data driven approach, we will be able to really extract the valuable information and develop. One thing is that develop a predictive models. We will be able to develop some predictive models. As I say, the modeling can be done with a number of other the analysis tools, but when we have a realistic data available, and then those data have been tabulated or maybe graphically presented, better we utilize those data and continuously improve. Then only the more and more better and better optimization, better and better product will be given to the society. If I say in a short term is, or maybe say in the summary point, or maybe lesser number of words, we say if we have a digitization under one tool, data driven methodology another tool, then if we combine these two, then decision making can be improved significantly and many operation can be automated. So, I will just cover one of example also, that how it can be automated. Another one, we say that based on this digitization and data which are available, data driven methodologies, we can develop a predictive models, and then which can be also verified by conducting only few experiments. Now, if I want to develop suppose a new model as such, I really require many experiments, but if I take existing data or existing graphs and convert or digitize those graphs and use a data driven methodology to really come up with a meaningful data, and then develop some model or predictive model based on that. After that, I may not really require many experiments to be performed to verify that. So, there is an insight already given to us, or maybe will be coming from those data, but to really whether everything is as per the reality, or everything is going to be good from that setup point of view, we need to conduct a few experiments. So, instead of conducting 10,000 experiments, we may conduct 100 experiments or maybe 50 experiments, and quite possible we may get a better results in that situation. So, what we say, by examining data, finding bottlenecks, uncovering trends on anomalies, and we can think about the digitization curve will be really bringing some sort of optimization, and that is what we really require. Of course, this also will involve a statistical analysis. We really require some statistical analysis to be performed. So, we will take a few examples related to statistical analysis. What will happen because of that? We will be able to identify potential dangers, estimated failure probabilities, and maybe we can intimate or related to risk, and we can mitigate those risk, and then we can take appropriate decisions. So, these are the important things, and that is why we say that digitization and data driven methodologies should be combined, and that is the future for a complete we say that this corrosion related course, or we want to really minimize we say that losses which are happening because of corrosion. Those are possible when we combine this kind of approaches, and then make appropriate maintenance strategies. Let us take some examples which we have already covered. In lecture 6, we covered the wear maps. So, these are the established curves, and if you go to the literature, there are many curves available. So, this curve is basically for steel, and then what was mentioned, that there is something like ultra mild wear domain which we really required. If you want a very long life or service life of the product, we should maintain an ultra mild wear. But how will we get it? Now, another there are mild oxidational wear, plasticity dominated wear, severe oxidational wear, and these are the curves available. I cannot really every time come and then compare with established curves as such. So, if we are able to digitize this, if we get those data and analyze those data and use a data driven approach to take appropriate meaningful data for our work, whichever is more like a dominating. So, we will be using the PCA where the most important factor will be considered. In this case maybe then there are many factors being given, but what will be the most important factor or maybe the few very important factor, those need to be picked up. That is why we say that we use a data driven approach and then those can be utilized. So, this I am just taking this example is for steel, there will be number of materials. Now, depends which kind of material we are going to choose, we can choose we can select the appropriate wear map. As I mentioned, there are number of wear maps already available in literature and we need to really figure out. So, we will even we want to do something new, we want to learn something new, better we use existing literature first, use appropriate methodologies to analyze the literature and come up the what is really gap, how many more experiments are really required for that, what kind of maintenance strategy will be appropriate considering experience of different researchers, different authors, and based on that we move ahead. So, that will what will happen, it will continuously improve our domain knowledge and it will give very fruitful results. When we do a totally new kind of experiment, quite possible 90% experiment which we do only gives our some sort of understanding to us. However, if we analyze the existing literature in much more meaningful way, quite possible we can really accumulate good knowledge and then start our work. So, that is the aim of this lecture, to provide that kind of approach. So, where you can really think about existing literature in a more meaningful way, not only some research has been done, some work has been done, that is okay. Now, we need to know really what is missing and how do we really improve our work. And existing literature will really give much more insight that what is what was happening, even some still behavior, one author is presenting some results, other author is presenting quite different results. But when we go with a data driven approach and digitization or combination of this, at least we will be able to know whether the data were noisy or maybe the one author had maybe a bad sensor and the data are not appropriate, or it was not well within a range of the sensor, or maybe some other typography errors are there. So, those can be diagnosed when we go ahead with digitization and data driven approach. And there was and also we presented one on the slide in a fractography lecture number 12. What we mentioned there that present approach is we should go ahead with the digital twin. What is the meaning of the digital twin? Says very clearly the digital twin is a digital copy of physical object or system, and then data, particularly in this case we know that every material when it comes in a contact, they will be releasing some sort of a debris particles. Now, if we are able to track surface from where the debris have come out and we are able to match debris size and dimension, that will be able to give us some sort of physical verification, or we will be able to construct a model, right. So, that is why we say the data from where debris source, it can be from a sensor, from IoT devices, or maybe simulation, if they are combined to construct time deteriorated system, and this is something new. This is the time deteriorated system with a time, how much deterioration, even including localized level, we are not talking about generalized one, localized level. If you are able to keep a track on that, that will give far more and a better understanding of the system, and it will cause a much lesser failures, even much lesser replacements, much lesser breakdowns, and it will can save really a lot of cost to us. So, that is why the digital twin is been and the name in this has been the famous, or maybe say it is really emerging. Sometimes we use a word this as a cyber physical system, and often people are confused. they assume cyber physical system means only the computer related system. It's not like that. Here we are trying to understand in situ or maybe present situation, what is the health of system. Like a human body, we know with age there will be some sort of deterioration, and some people will have more knee problems, some people will have some more finger problems, some body problems, some stomach problem, whatever. Every system, every human body, maybe at the beginning may be same, but every system is developing different kind of problems. So, if we have a digital twin and then we have so many systems, quite possible even suppose a gear pair, one gear pair faces one kind of problem, other gear pair faces another kind of problems. So, naturally the remedies also need to be different. I can't say that if you have a stomach problem, still you take a headache medicine. So, same thing will happen in this situation. We are trying to really replicate and the deterioration system using the wear debris analysis, and if it is done, then it will really give a very good results. As I say, if we are able to reduce the deterioration, if we are able to reduce what we say the replacement of the product, naturally the damage to the environment will come down and significant saving in our products component subsystem will happen. So, as I mentioned, this cyber physical system does not mean it is related to computer science, it is very much related to us, and then here it gives a real time insight into the state of the physical asset or maybe the product or system, and then what are the chances of the failure. It can predict the failure well in advance. In addition, it really gives a some sort of help to think about a maintenance, how frequent maintenance is really required. Few systems may not require maintenance at all, there is no initiation of the crack at all. So, then why do we really go ahead? And for the time being, we know the condition based maintenance or something we will be covering maybe next to next lecture, that kind of case study, and we know that maintenance becomes important if we have a sensor suite attached to that, and then if the sensor suite which is really giving data and we are using the data driven approach along with those data, then it will give a very good results to us. Now, I will cover another one slide which has been picked up from lecture 20. Now, what was mentioned there is we say that TT is used to get an image of the thermal image, and then that will have a lesser what do you say that signal to noise ratio need to be improved, and then the good kind of filtration system is really required. And then in this case we have shown that the 16 to 18 defects out of 30, and then if your thickness is increased, then number of defects are defects which can be detected are lesser. As a further increase in the length or the thickness, the number of defects will be further reduced. So, thickness related variation was shown. Now, this system itself will have many variables. How do we diagnose each variable appropriately? That is why we say that the authors in that situation, in those cases, they use the principal component analysis, which will be covered in our next lecture. However, I am giving some time on this topic because it is a very important topic as such. We have heard about eigenvector, eigenvalue, we have studied in mathematics, maybe the class 12, and then we know that that gives many the principal dimensions, the dimension where the maximum impact is happening. If we know the principal components, if we know the main component, we can focus on those components. Not necessarily we have 100 variables and start thinking about 100 variables. So, this is a technique to filter out. So, that is why I say the goal of the PCA is to condense many dependent variables into manageable subset. So, if I have 100 variables and impact of almost 90 variables is only 5%, do I need to consider those? Or shall I go with a much more robust system, because those variable 95 they will have a lot of randomness or maybe some sort of variation which will not be able to control. So, it will not be manageable. So, that is why we say that the PCA is really will be helping to reduce dependent variables into manageable subset, and this is very useful wherever there are many variables. And that we last time mentioned, when we are going for the defect analysis or defect capturing, it will have many dimensions or maybe many types of variables, in that, and then we need to really filter and come up with the right results. And in this paper, and that the paper which we covered, and in this paper only PCA was used to get a more meaningful results. And then we say that wherever there are many variables should be addressed properly, and then we need to really filter out what are the really more significant variables which have a more impact, and which we need to control on those variables to get a much better results. Now, that is why we say that we are leveraging on the data driven approaches, and then I say the next lecture we will be giving some weightage to the maintenance, and we will be covering there the more predictive maintenance. So, for predictive maintenance I prefer to go ahead with the data driven approach, even though we have many algorithms already there, many sensors are already there. It will be always better to go back to the literature, see what is the trend, make some sort of model, and then apply and continuously improve based on our data which we are getting through the sensors. So, that is why we say the data driven and the predictive techniques utilize historical data. That is why I am using the word. It really uses the historical data from the literature, sensor measurements also, and then advanced analytics, something like a PCA can be utilized to forecast a machine performance also. Maybe whatever will happen after let me say 5 months, 6 months, that can be predicted using this kind of thing. Even when we do this kind of data analysis, we can discover the patterns or indicators which really indicate when the failures are going to happen, what kind of possible failures will happen, and that is why it will really help maintenance team to take preventive actions and measures before any breakdown occurs. And as per my knowledge, if we go ahead with this kind of data driven approach, breakdown may not occur at all. May occur only when we do not have a sufficient knowledge about system, or something badly is going to happen which is not under our control. So, now as I mentioned that next lecture we will be covering on condition monitoring, preventive maintenance. We say the condition monitoring is critical for the predictive maintenance, and then it allows real time monitoring of the equipment conditions. Now, sensor data which will be gathered and analyzed, it really can provide some sort of deviation from a normal operating conditions. So, again what are the normal operating conditions? We need to know from a literature, from a historical point, and then once we have those data, then we can say these are the normal operating condition, these are the deviation from a normal operating conditions. So, there the historical data are important for us. And in the previous lecture I mentioned a weighted objective technique. We say that it is a way to quantify a state of asset health, or maybe say system health, by combining the multiple indicators. So, we mentioned that we can really choose many variables, many factors, many indicators, and then attributes, and then we can really come up with which technique or which scheme will be the best, and then digitize strategies and combined with a model can be trained. Now, here we using the word, we develop a model and that improve the model based on the data which we have collected. So, we will be really utilizing the collected data, the new sensor data to train the model, or however if we have a good historical data available, we can make a model initially, train those based on those model, and then we refine based on experimental results which we are going to cover, or maybe we will be obtaining. So, determining the basically the what will be the optimum strategy. Again, optimum strategy which we get from weighted objective method may not be foolproof. Reason being that we are taking those decisions based on available data or maybe historical data, and as we start working on maybe IoT based and we are collecting the more and more data, this again strategy can be modified in situ also. So, if we have automated algorithm available, when we do a good coding, there is a possibility that even dynamic situation, that weighted objective optimization method will continuously be improved, will be changed also. Now, we say the predictive maintenance model can be refined over the time with input from a maintenance activities. So, whatever activities in last 6 months has been done, now that those can be utilized to improve the predictive maintenance model, and then go ahead with a better strategy, and we say new data collected after maintenance measures should be utilized. Optimization of maintenance schedule, prioritizing component replacement, and then whatever the recommendation we want to give will be useful in this case, right. So, we want to give some sort of recommendation, maintenance should be done immediately, or maybe components should be replaced, those can be given. So, information will be available with a maintenance person who is really going to operate the system. Now, how do we go ahead? What is really the method to digitize? There are several methods. However, we are assuming there are some normal softwares available, and in our course also the MATLAB software will be available with you. The company will provide for the course duration from July to the October. So, those softwares can be utilized. However, in this case what we are saying that when we think about the digitization, we say that even the graphs are treating this as image digitization is possible, and then it is basically to transfer the graphical representation to digital one, which I already mentioned. Here we are trying to cover this by software which is origin available with us, but it is you can utilize any other software also. How do we operate this? We need to launch the software, and then when the file open gets when you are launching it, now this this kind of the menu will appear. You can open a new project, you can name that project, and then you can import the file which you want to convert in a digital format. Once it is done, we need to really locate the reference points, because we really require a calibration. Whether we want a graph in 5 mm, 0 to 5 mm, 0 to 100 mm, 0 to 10 meters, that reference we need to be selected. However, in this software itself there is a measurement tool, so that can be given as a reference object, the reference point, and then all the values can be calculated based on that. Once that is done, then we need to really think about the software need to be given instruction to track the image, so that the digitization process can be started, and once that is done, then all the data can be collected or can be extracted, and the software will be able to give data, and then there is something like the option available, we can collect all the data to our side. Now they have a number of formats available. Now next model or next software, whichever we want to utilize, either Excel sheet or MATLAB or some other software, you can collect the data in that format. So whatever the graph available can be converted to digital form. Either you go have at the points which are available on the graph, or you go with a line, maybe you want 100 points or 500 points or 5 points, depends on you, you can select that. So now here the data extraction, we say once the characteristics have been traced, convert them in numerical data. Depending on the complexity of data, technology something like digitization or data extraction can be utilized, and then we will be able to collect the data and then store the data. Now in this case we are going to concentrate only on xy coordinates, but there is a possibility we will go with a 3 coordinate xyz also. For this course we want to just stick to the 2 coordinate system, x and y, and then maybe y and z, or maybe z and x, but 2 coordinate system only, we will not be worrying about the 3 dimension. Those can be done in a sophisticated, maybe the more advanced courses, but for present purpose we want to go ahead with only 2D graphs, and then we convert and digitize those graphs and we come up with a meaningful results. Now suppose we have collected the data, and as I mentioned, if you do not have origin, you can collect the data manually also. If you know the 5 points, so I really require 5 points or 10 points, we can plot on the graph paper, and then we can directly get those data also, and we can feed those data. Now how do we go ahead with the next step? One method is go ahead with a curve fitting. Curve fitting is also established method. Curve fitting also happens in a MATLAB. and curve fitting also can happen in Excel sheet. So, depends on what we want, we can directly come to the MATLAB or we can utilize the Excel sheet. For completeness, I am explaining in this slide on the Excel sheet first. So, you see that we need to, because we have Excel in our system, Excel 365 that can need to be launched, and we need to really open a new spreadsheet to organize the collected data, whatever the data we have either manually collected or from origin software, those can be utilized there. And then we need to, in Excel sheet we can have a X column as a one column, and we are assuming the X in this case is independent, and then it can be varied and it will affect the value of Y. So, Y is a dependent on this case. So, the X and Y, X is a independent, Y is a dependent, and now we do have option, we can go ahead with a scatter plot or we can think about the trend line also. So, if I have a 5 points or 10 points, I can go with a scatter plot. But if we want some sort of trend analysis, we want some sort of mathematical formula to be utilized later for some other purpose, not only the scattered data. So, that is possible. This is also possible. When you think about the trend line, Excel sheet has a number of options. Now, we know that the exponential is a one option, linear is another, logarithmic, polynomial, power, moving average, these are the some sort of trend lines available in Excel sheet. That is why I am trying to utilize, and it is more common, like almost every system has in these days MS Office as a given to the students. So, you can utilize those kind of things also. Now, in this case another one is a trend line. When we talk about the trend line is having equation as well as the R squared value. What is the R squared value, we will discuss later, and then we can add directly, it will come as a equation form on a curve itself. We will cover a few examples on that also, and then it will also display R squared value. So, one is a trend line, equation and R squared value, those can be really obtained using Excel sheet, maybe say the Excel software based on giving as a input of whatever the current data which we have collected. After that, we can think about plotting those data. May not be really required, but the completeness we want to see whatever we did a digitization, when I am plotting, am I getting the same thing or I am getting something different. Right. Now, why we are talking, we may collect the data from one source, another source, third source, fourth source. When we use MATLAB, we can compare those, we can find out what are the differences in this, and then we can use a data driven approach to really analyze why the difference is coming in those data, that what is really different. So, when we do a literature review, we do not really look at and one go all those things. Once these data have been converted to the graph or maybe to the plots, and then we have a number of plots maybe from various resources, and then we find that there is a huge variation in those value, then we try to diagnose, and then we can figure out what are the gaps between. Or maybe then one author has used a temperature like a 30, other author has used the operator temperature 70, and then they did not really use those 30 degree and 70 degree in their model, and now because of that there is a difference in a value. Now, if I want to add after that the temperature as one of the variables, that is also possible. So, that will give more and more realistic value, more and more creativity, more and more we say the possibility of innovation. Now, in this case we have used, there are number of plot function in a MATLAB. We are talking about the fplot or function plot in a MATLAB, and then for this code has been written for the one simple function, that what we are saying that f is a function and the f is equal to fx is equal to x square, x is a variable. So, in this case fx is basically like a y. So, when I say x and y, so here fx will be y and x is equal to x is equal to x is a independent variable. For time being we are keeping this in the range minus 5 to 5 or plus 5. However, it can be minus 1 to 1, maybe minus 10 to 10, depends, or maybe even the different value minus 1 to 5 or minus 5 to 1, anything is possible. And then based on that, and after this we can add a title, the access label or legend, whatever is really required. We can think about the different kind of the plots whichever really required. So, if I am collecting the data from 4 or 5 different resources, variables, naturally I will change maybe one red color line, one other blue color line, or maybe somewhat difference, or maybe some dashed line, a thick dashed line, those things are possible. So, this is what is available, and in this case you can see the MATLAB code. We have written very simple, f is equal to the function of x square, then comes as I mentioned the range. So, we have given x range as a -5 to +5 is independent, we can give this one, then we are plotting the whatever function and the range. Now, we have not given what is the increment or division, the software will decide its own. Then we can plot f, and then in this case we can really define what is x label, what is a y label, and as I mentioned here that here f x itself is treated as a y. So, that has been mentioned under this figure. Now, let us take an example this which we have also covered this figure 1 and figure 2 in one of our lecture, where we were trying to figure out what is the corrosion of aluminum 7075, and it has some sort of a nano composite along with aluminum 7075 and in environment of S2SO4, that is the acidic environment. In other environment we use HCl, and we know very well that deterioration or maybe the corrosion rate initially is something like a 0.15 in S2SO4, while in this case HCl it is much lesser, almost 50%. So, HCl is much lesser harmful compared to the S2SO4. However, in that we also use NaCl that was a much lesser effect compared to this acidic environment. Now, when we are digitizing, what happens in this case, we are able to find out, as I say, that there is a trend line. So, this is a one trend line, this is another trend line, the third trend line, fourth trend line we have used in a Excel sheet. So, we use a origin software to collect the points. Based on the collected points we have plotted. So, this is a plot of this figure, and then this second figure we will be covering in the next slide. Now, when we are fitting here, we are giving this r square value, and then this is the polynomial equation, and that is a second order. Now, we have mentioned clearly, so all the curves are polynomial, x square is a common, x is there, and then some sort of constant value. Now, this as I mentioned, this figure, this and this figure, first and second figure has been picked up from this literature, and this has been already covered in previous lecture. So, what now let us there is a meaning to give upon some we say that some information on r square. We say this value indicates what is the really how well the regression model is fitting, whether really whatever the model we are thinking, like in this case y is equal to 5 into 10 raised to minus 6 x square minus 0.0017 into x plus 0.1584, whether this model is really fitting well. So, that is indicating here 0.9999. So, it is very good. That is why we say this basically indicates how well the regression model fits collected data, whatever the points which we have provided. Now, this is a statistical measure, as I already mentioned that when we are talking about the data driven approach, we need to really stick to the statistical approach or statistical measures. And now, it depends how much variance is happening with a dependent variance is happening between dependent and independent variable. This r square value generally varies from 0 to 1. It is not a -1 to 1 because we are using the r square value. So, it varies from 0 to 1. And what is the meaning of 0? 0 says the value of 0 implies that dependent variable can't be explained by independent variable as such. So, these two variables they do not have a correlation, zero correlation, they are not connected, they are not interrelated at all. Well, coming to the value of 1, what it says the independent variable has a complete explanation, or maybe the way very strong dependence and the way we have given this as a model is really matching well. Everywhere you can see 0.99, 0.99. So, these are the models very suitable to this model. Now, this is what we use using the Crawford method of Excel sheet. It is very good to give some sort of understanding what kind of relation is there between the dependent variable and independent variable. This gives a relation between the two maybe say one independent variable, another dependent variable. Similarly, we may have a 2 dependent variable, may have a 3 independent variable, we can do digitization of those things also. Now, coming to the second, in SCL case, we are able to see here, this is what the comparison has been shown. Yeah, sorry, now in this case we are giving the second the slide also on S2SO4, and next slide is on SCL. The S2SO4 which we say that this is the MATLAB code, which is again very simple way of writing the function 1, function 2, function 3, function 4, and then it is related to 2%, 4%, 0% on hybrid nano composites. And then we are able to really see the results. This is kind of a perfect match with this, and then the green is a fact and the perfectly matching with this also. So, we find very good correlation and then perfect matching, that when this kind of model can be utilized for a initial purpose for our system. So, even though this model has been picked up from a literature, but it has a good correlation at least with one variable, that is a time. Now, if I think instead of the time, I also should develop a relation for the nano composite percentage, then which the literature has not given the 2 variables, they again have given what is the variation with the nano for the 0%, 4%, 6% and hybrid, and then they consider some time period for that. So, if I do digitization of that also, and finally, I can combine 2 variables, I can come up with a 3 which is the y1, y2, and then the variable x is independent. So, in that case we can really get a good results, or maybe say y as a 1 function, that is a corrosion rate, and then I can think about x1 as a time, x2 as a percentage. So, depends on the how what kind of results I want, we can really do good data manipulation and then come up with a better understanding, better insight that what will be the impact, of the percentage individually, time individually, and when they are operating together, what will be the overall correlation, overall relation for that. So, this is S2SO4. Now, we are coming to the second one, that is the SCL. As you see, the SCL is a less harmful, again we are getting good correlation for that also, 0.9954, 0.99, the almost very good correlation, and we are able to reproduce the same thing in the MATLAB. So, whatever we are getting from literature, similar relation or similar kind of curve we are able to reproduce here. This does not mean that we want to do any cheating with in the system, this is basically to understand now how or what is really happening. And if I understand the system, existing system, or maybe established literature well, then I can think about something new on how it will be really utilizing for my own purpose or for my own industry, how really I can give a benefit to the society based on this knowledge which is already accumulated or available in the literature. So, again the simple here we can see the relation has been written here. In this case we are getting and the 4 and then we say the 10 raised to minus 6. And 4 into 10 raised to minus 6 here, 3 into 10 raised to minus 6, 3, 2, 1, same relation we are able to code, and we are able to plot what is really required, and we are able to compare. This is a more like a perfect comparison, red color line, green color line, and the blue color line, and then violet color line. They are perfect matching, is very good. Now, coming to the second case which we also have covered when we were thinking about eddy current testing and eddy method, we found that in the corrosion increases with the time. This has been shown that the 3 months spread is much lesser. With after 6 months you can see the spread has increased, and then after 10 months the spread has further increased, and then the authors really provided 3 values. That is this you can see that they took 2 examples, coated and uncoated, and we know that in their results they found that there is not a significant variation whether you are coating or uncoating, or maybe without coating we are utilizing it. So, this is a kind of this curve indicates how the passivation occurs in this situation and how the corrosion height is also changing with the time. So, with the exposure at the time the corrosion height is continuously changing, increasing, porosity will increase and chances of failure will increase. So, this is what already this slide has already been covered. Now, if you want to digitize this, we can take this as example this figure, as example. Now, only thing is the number of data points which are available in this case are much lesser. So, there is a 1 data point, 2, 3, 4. So, the 4 data points we can be utilized for this purpose. In other cases we have only 3 data points. So, now this also indicates that if we have a lesser number of data points, curve fit option will not be really giving very good. So, if a number of data points are more, then it will give a good results to us. Now, here you can see that the regression earlier case it was almost 0.99 something, while in this case instead of going for the polynomial, we have try to fit a logarithmic relation, which is getting better results compared to the polynomial. That is why here the log plot has been, the log relation has been established. You can see here that in one case it is the 0.9987, while in other case it is a much lesser, it is a 0.93. However, we keep a limit. If anywhere the correlation or R square values are lesser than 0.9, we should reject it. We say no, this is not really good data, we will not analyze this. However, in this case 0.93, and then we are able to give this the damage, we are able to differentiate little bit that damage on the coated surface is slightly lesser compared to uncoated surface. And now here the whatever the relation we have developed is the same thing has been given in a MATLAB coding. You can see here 0.0148 into log x, that has been given in this relation, and this is a constant. Same thing happens in the next case also 0.104 is the value here into log x, and 0.0182 that is a constant value. And then we are plotting figure 1, F1 which has been plotted in the red color, F2 has been plotted in a blue color, that has been shown over here. So, then again there is a good matching, we are getting good relation except the red color which has a lesser we say that correlation constant. Of course, correlation constant alone cannot be major criteria, but it really provides some insight that whether whatever we are doing, whether there is a good correlation or there is no good correlation. As I mentioned that as per my understanding, 0.9 should be the kind of borderline. If the correlation coefficient is going lesser than 0.9, we should think there may be either some other relation, or maybe we need to repeat the experiment, or we really require some sort of more insight in those kind of results. Now, the same thing in other curves we are mentioning here. Now, you can see here again the 3 points has been given as a red color, 4 points, and then here the 3 points, and then what we are getting correlation in one case it is a 0.91, and this is a blue color, and you can see here that there is a deviation happening. Now, correlation is we are not getting very good, so there is a deviation is happening, even though that we have made a this function in MATLAB, and we are plotting. You can see F1 plot is a red color which has a good correlation, but this F2 which has been plotted in the blue color, there is a big separation. So, this I am not able to see much separation, while when we think about MATLAB coding we are able to see much separation. So, as far as possible we should go for the high correlation constant, or maybe if it is not both not following a logarithmic, then quite possible I need to change this relation, but that will not justify. If I change a relation, it will not justify. Maybe in coating case it is really following a logarithmic the variability, and while coming to the other uncoated one, it is not really following the same thing. So, there will be, or maybe if it is, then we need to understand why it is really happening. So, it will provide some more understanding. Now, this approach why we are doing, we are trying to understand the existing system, how this dependent variable is really affecting maybe independent variable is affecting the dependent variable, and what is really the measure of that. So, that has been done. Now, in the last one, this is only one data point has been given, and then we are getting also good correlation. So, 3 logarithmic cases, 2 cases we are getting good relation, 1 we are not getting very good relation. So, either that experiment need to be repeated, just an indication that that experiment need to be repeated. Sometimes this kind of approach also help us to understand, maybe when we were performing some experiment, some data which we got, either maybe the signal the problem, or some sort of problem, or maybe the variation in some sort of humidity or maybe temperature, and those needs to be changed. So, this case also we are getting perfect matching because of the high correlation. That is why I give a lot of weightage to the high correlation, and then the correlation coefficient is a correlation coefficient on higher side, we can believe in this. The correlation coefficient is not very high, then there is a doubt, and then if possible we should repeat the experiments. Now, last one here in this the sequence I am taking again ultrasonic and one testing, and then this also complete slide has been shown in my previous lecture. We say that this ultrasonic testing can be utilized to diagnose defects. However, if you look at diagram, the values which we are getting a lot of overlap in data. So, there is not a clear cut difference, and then if you look at this one also, the data are very scattered. This scattering of the data creates a lot of confusion, and then this indicates that we really require refinement in the results. We require to utilize maybe say more sophisticated techniques for the betterment of the results. Now, look at this data also, we are getting some high value here, then low value here, then high value here, then again low value, then high value. So, a lot of randomness, even though this is a kind of a mass decrease rate, reduction in a mass, that should follow some sort of uniform trend. So, this again is coming when we are trying to utilize a digitization and data driven approach. We are able to look from that point of view, that this is something when I am trying to digitization, I do not find a kind of regular pattern, and then when we try to look at this, one question comes whether these data are sufficient, do I require a repetition of data, or I think that curve fit method may not be suitable at all. So, let us see what is the curve fit results in this case. Now, in this case we are plotting energy versus the corrosion period, that is a time. You can see here the corrosion and correlation, we tried three things. One is polynomial, the correlation coefficient is a 0.90, while we go ahead with the linear curve, it is still 0.86. When we go with exponential 0.778, we can go all 6 kind of relation, but this is just for understanding purpose. So, now energy versus electric corrosion period we are plotting, we find that the polynomial is giving the best fit 0.9015, but still I believe that need to be repeated, and then we do not find that kind of results. Same thing as we mentioned earlier, that whatever the function we get in Excel sheet, we are trying to plot and then compare and to see the results, and you are able to see clearly here the data are very scattered, and these are the realistic cases. Many times we get a very scattered data. If I do a curve fitting correlation coefficient, that is one possibility. Other possibility is that go for the better techniques, and better technique in this case is generally the PCA. Go ahead with the machine learning algorithm, try to modify not only this, whatever we do curve fit we limit. If I want to go with the next experiment, again curve fit method may not be giving the good results with that. Again I have to go for the re-curve fitting, maybe in the refitting of that. So, instead of that we go for the better approach that will give a good results to us. Now, look at maybe that was on the versus side, this as I mentioned that already there is a randomness, lot of randomness as such, mass decrease rate sometime increasing then decreasing, and then this is basically from a distance. Now, and then there is some sort of attenuation of the sensor signal, and then where a crack width also there is a change in the crack width, even though there is a crack, and then what we are able to predict, if we are able to predict a constant value, it makes a lot of sense. The constant value, the crack is not changing, and whatever what I am measuring from a 7.5 centimeter and at the 67.5 centimeter away, the crack length is a constant, so it is not having any effect. But when we try to find, we find there is some sort of a polynomial curve fitting coming, something like a the 0.001 into x square, and the regression coefficient is 0.66, right. Coming to this blue color line, we do not find any correlation at all, while constant value I can see that this value should have a constant value something like this from here to here, but there is a variation, and still that is fitting from a polynomial point of view. That means, as the distance increases, that quite possible this crack dimension will change. So, from starting is a lesser and the crack dimension is increasing as it is increasing the distance. So, again this is not a really correct results. And another thing is while coming to this mass loss, mass decrease, that also has a very random results. So, instead of that we say either we go ahead with a higher polynomial curve, something like instead of x square, if I go with the x cube or x4 or more and more power series, will that be a better results? There is a possibility, and then we need to explore that, and that is what we have done. You can see here even the 9th degree polynomial and 10th degree polynomial has been fitted, when this is a wear mass and this is a crack width dimensions have been shown, and then we are seeing there is a good correlation happening 0.90, 0.991, but you look at the equation and many times we use a word this is a overfitting. Now, if I come up with a new dimension, one of a new data value, again I will find that is not matching with this. So, instead of going for this kind of higher series, it will be preferred to change the method and then go for the kind of machine learning or PCA, and then we try to figure out which is really impacting more severely and then which is not really significant, and that can be done when we do PCA, and that will be covered in next lecture. Thank you for your attention.